This is a confession video. I'm here to tell you that I have never gotten a decent image of the Horsehead Nebula. That's right. In all the imaging that I've done, I have never captured the Horsehead and flame. Now, I tried many years ago, and I had terrible results, not worth sharing with anyone, but I'm going to anyway. So this image was taken quite some time ago, and I've had a lot of experience since then, but I haven't revisited this target. Why? Well, I don't know. It is one of those common targets that everyone does, but then again, it's such a beautiful target that I can't not aim for it. So tonight, I'm going to use my 300mm NIKKOR FED lens with my ASI294MC Pro Camera to capture the Flame and Horsehead Nebula. But that's not all. So those of you who've watched my channel before know that I'm constantly trying to improve ways of doing polar alignment for a telescope on a wedge. Now, for some time now, I had the idea of putting a polar scope onto the NEKKOR mount. But my Celestron NEKKOR 6SE, or the ASI mount, it's the same mount, has no right angles, which means putting a polar scope onto that mount is very tricky. But tonight, I'm not using that mount. I'm using the SLT mount with the shorter focal length NIKKOR lens. And that one, tonight, I have running on a Astromaster mount that I've repurposed to act as a wedge with a Vixen dovetail. That Vixen dovetail sticks out further than the SLT mount sits, which gives me a little bit of room to attach something. So what I've decided to do is to use a red dot finder on a 90-degree bracket bolted to the end of that Vixen dovetail. It's at a right angle and it's going to be pointed straight at a perpendicular angle to the mount, which means, in theory, because this is a 300mm lens that I'm shooting with, and I don't need to be that accurate, I should be able to more or less eyeball Polaris through the red dot finder and have good enough accuracy for guiding for this focal length to be able to image tonight. Let's find out. My name is Chris, and welcome to my channel. I have to say I was getting a little bit worried. You see, my backyard is in a location that is a Bortle 8 sky. Bortle 8 to the south, Bortle 8 to the east, and slowly transitioning into a Bortle 7 towards the west. But at that point, towards the west, much of the region of the sky is hidden by neighboring homes. So in the direction that I usually image, it is a pretty bad sky. Now, what I had going for me is that it is pretty cold outside. It's getting cooler and cooler, and we are below freezing. So the sky was a little bit calmer than it normally is, and we didn't have much wind. The clouds were supposed to be coming in pretty early, which gave me just a few hours to get set up, get my polar alignment done, get my focusing done, get everything ready, and to do all of my imaging. So I wasn't sure if maybe an hour and a half was going to do it for me. Now, the reason I was getting worried is because I've seen some really beautiful images of this region of the sky. And the really nice ones were the ones that took many hours, 5, 10, 15 hours of integration time. to really expose the nuances and the deeper areas of the nebula that are fainter. I'm also imaging in the middle of the week, and it's kind of a work night, so I wasn't planning on staying up too late. I was just going to get the setup going and then let it run and go to sleep. Well, that didn't happen. So being concerned about the clouds rolling in, I stayed with the telescope a little bit longer just to get it to the last possible minute before I changed over to taking my flats. I was using my UPPD matte flats along with standard darks, which I used as dark flats. That way I was getting the benefit of getting the hot pixels removed with the dark flats as darks, and then the advantages of the UPPD matte to deal with any additional light pollution caused by errant light coming into the lens. For imaging, I was using the ASI294MC Pro Camera, so that's a one-shot color camera that is cooled. I did not turn on cooling until about halfway through, but because it was cold, the temperature was already around -7 Celsius, and my normal cooling I set down to -15. The images that I took 30 minutes of 60-second exposures using the UV IR cut filter to capture the stars. And then I took 3-minute exposures for 1 hour and 21 minutes using the dual band filter at a gain setting of 240. And that managed to get me some pretty decent signal to integrate for the actual nebula itself. Now, the 30 minutes that I took using broadband, I was only going to use for the stars, but there is a bit of a reflection nebula just to the right and just below the Horsehead itself that really came out in the broadband pictures or the broadband images. So I actually kept a layer of broadband to integrate with the dual band to combine the reflection nebula with the dark nebula and the hydrogen alpha coming through from the dual band. So this region of sky is actually very cool. It's part of the Greater Orion molecular cloud. Try saying that 3 times fast. The Horsehead Nebula itself is actually a dark nebula that obscures part of the hydrogen alpha star-forming region known as IC434 in the shape of a horse's head. Just to the side, so I guess if you're looking properly, so to the left of IC434 is another star-forming region called the Flame Nebula. Now the Flame Nebula is designated NGC 2024. Given that this is 2024 or the tail end of 2024, now would be a great time to image this target. What makes imaging this area difficult is right between the Flame Nebula and IC434 lies Alnitak, the leftmost star of Orion's belt. And to the right of Alnitak lies Alnilam, the second star in Orion's belt. Both of these are supermassive blue giants, and they are very bright. So when imaging, it is very difficult to balance the gain and exposure times in such a way as to not overdo the brightness of those 2 stars while getting a good amount of data and signal on the nebula. And I think that by imaging the stars separate from the nebula, I was able to find that balance, at least as well as my 300mm lens would do. Now the other thing that I find is that 300mm is a very good focal length for this area because you just managed to get all of IC434 right out to the edges, as well as the Flame Nebula, and capturing some of those really bright stars in the area. Now at longer focal lengths and with a wider aperture, I would have been able to see more detail within the flame. And some of that detail is really, really great. So I think what I'd like to do in the future is re-image this region with my Celestron NEXTAR 6 SE at 150mm aperture and 945mm focal length. Putting all of that together, I think would produce a much sharper and more detailed image of the area. Ha! I almost forgot to add. The experiment with putting the red dot finder perpendicular to the dovetail worked remarkably well. My error was between 2 and 3 to begin with. That's 2 and 3 arc seconds. And then it eventually settled down to around 2 arc seconds, which is really good for this focal length. As a matter of fact, it would not have been terrible for the 6SC at 945 millimeters. So using this approach with a little bit of drift alignment, I think it would work quite well. So look for me to try that out in an upcoming video. For now, I'm actually quite excited about how well this area turned out with just 1 hour and 21 minutes of hydrogen alpha and oxygen data and a half hour of broadband. And so I'm going to post the final image to the end of this video. For now, and as always, thanks for watching and clear skies. It's part of the Orion Molecular Cloud, or the Greater Orion Molecular. It's actually Nebula. Greater Orion Molecular Cloud. Orion Molecular